Dear students, welcome to CR's digital classes. Today let us learn the concept of Wolfowitz Run Test. So what is that run test? How it goes on? Let us learn. So here Wald Wolfowitz Run Test we have. So if x is equal to x1, x2 so on up to xn we have represents random sample of size m drawn from the population f1. So one population I am considering here random sample from f1 as a size m. So one more population, let us consider one more sample y, capital Y is equal to y1, y2 so on up to yn. One more sample of size n from the population F2. I am considering some populations here, like we can't consider normal or binomial, right, because it's a non-parametric test. So for suppose we are taking some assumption here as F1, F2 like that we are considering, and we are trying to get some formula for run test. Now how the procedure goes on, let us check it out. So till now we have considered two samples out of some populations. Next, based on the above assumptions, hypothesis test will be H naught. So again we'll write here hypothesis also, null alternative, test statics, everything will go on as we do for small sample, large sample test. In the same way we'll go on here. Only thing is that particular specified populations or mean variances will not get for non-parametric. So we'll consider the procedure same as a testing of hypothesis procedure. So let us check it out with the null hypothesis, what it is framed as. So H naught, the two populations F1, F2 are same we are considering. That is H naught F1 is equal to F2. So null hypothesis I am framing it as the populations are same. Now next alternate, what alternate will be? Just like the other hypothesis, the alternative hypothesis will be H1. The two populations F1 F2 are different. So obviously we have learned in before units, like alternative is opposite to the null. So null equal to we have considered, obviously alternative will be not equal to, that is F1 not equal to F2 will be a alternative hypothesis H1. Now these are the assumptions and null alternative hypothesis we have done. Now let us check it out how the run test formula goes on. So Wald Wolfowitz run test is usually performed as under null hypothesis H naught fx fx is equal to fy for all x values. So here I am particularly as a notations I am considering here the same f1 is equal to f2 only, with the notations of random variables I am considering here. So let us check it out here, the procedure. So alternative hypothesis, null and alternative hypothesis we have taken here. So let us check it out, the procedure, how it goes on for run test. So if we consider m is equal to 5 and n is equal to 6, then the combined statistics will be x is equal to x, y together combined data I have considered here, and I am specifying the runs here. So x1 y2 from x set of one run, y set to second run, and then from x set to 3 4 from x set, from y set 5 6 7. So like that set of runs I made. So number of runs will be 7 I've got here. So in this way I've got 7 runs here. So next what happens after getting the runs, let us check it out. If R, the random variable, represents the total number of runs obtained after the pooled order arrangement of mx and ny's. So after arrangement of the runs, what happens next, let us check it out. Then for small sample, the decision of H naught at alpha level of significance will be. So here in this non-parametric test, if sample size is small, then according to the non-parametric, according to the run test will give the conclusion. If that goes for the large population, we will again extend it to convert it to the normal population and will have a Z conclusions, what we have discussed in large sample test. So here if it is small, that is non-parametric test, this could be the result, that is capital R less than or equal to small r. Then we'll consider it as accept H naught. So that becomes a conclusion. So where R alpha is the largest integer. So that is a table value we call. So largest integer we'll consider. So in that way we'll give the conclusion, that is if probability of R less than or equal to R is less than or equal to alpha under null hypothesis, with alpha percentage itself we'll try to consider our comparisons directly, and will give the result here as accept or reject. So whenever our calculated value, that is runs whatever we got, if it is less than or equal to alpha, then we reject null hypothesis here. So we have different conclusions for non-parametric tests. So for run test, this is the conclusion. We'll compare with alpha percentage and our ranks whatever runs whatever we have considered. If it is less than or equal to alpha percentage, then we reject the null hypothesis in this run test. So H naught, if R calculated is less than R tabulated, then we reject a null hypothesis. That is a conclusion if we have a small sample. Now if that goes to large sample, the data if extends more than 20, check it out here. The reason they have given m greater than 20, n greater than 20, if they specify, means whatever the samples, whatever the data we get, check it out the data if they are more than 20 sample sizes. So we have to go for the normal distribution again. Now what is the formula for normal distribution and all? Let us check it out. So, and if the critical value of R cannot be found in the table, then in such cases capital R can be normally distributed. So we have considered R value to compare our runs and all, right? So if that is also cannot be obtained using the tables, then in such situations also capital R can be the run test can be obtained through the normal distribution whenever sample sizes are larger also. So let us check it out. The standard normal formula itself will use here, that is Z is equal to, because run test we have R we are specifying here. So R minus mean of R by root over variance of R becomes a formula for us. Now again, what could be the mean and variance formulas? Let us check it out. So the above formula is called as normal deviate. Yes, we know that normal, standard normal, variate is that. So in that R run test as R we are specifying here. So mean formula will be R is equal to 2mn by m plus n plus 1, and variance formula is 2mn into 2mn minus m by m plus n square into m plus n minus 1. So these are the formulas you need to learn. If at all data is more than 20, the samples are more than 20, any one sample also they specified more than 20, means you have to shift to normal population formulas and you have to obtain z value, and you have to drag the conclusions accordingly. So this is your formula when normal distribution. If sample size is high, we'll go for normal distribution. So let us check it out the decision also, how we'll go for decisions using a large sample test. The same decisions here also. Let us have a glance on that also. So decision will be for large sample, check whether Z calculated is less than Z tabulated or not at the given level of significance alpha. If the result is true, accept null hypothesis H naught, else reject it. Yes, the same conclusion what we drag out of yes, the same conclusions what we drag out of large samples, the same additions here also. If calculated value is less than tabulated value, go for accepting null hypothesis, otherwise reject it. So this is your run test. Wald Wolfowitz Run Test. And now what is the purpose also, let us have a glance here. So purpose is, this test is used in some cases where parametric test cannot be used. Yes, this test, all the non-parametric tests are utilized when parametric tests will not work out. So this is also one of them. So the main purpose of two sample run test is to find whether two different samples are drawn from the same distribution or not. So here always we'll get two distributions, right? Two samples we'll get. So we'll try to check it out from the same distributions they are dragged out or not, is the main purpose of this run test. So this is the concept of run test and its purpose. So hope you have understood this Wald Wolfowitz Run Test, how the formula is utilized, how the runs are made and all. So hope you have understood this session. See you all in the next session. Thank you.